Welcome back. In this video, we're going to get a little bit fancier with the empirical rule. So I've got my empirical rule diagram from the last video, and I've got my same kind of practical scenario. I'm trying to evaluate anesthetic use among dentists, and I know I've got an average or mean of 79 with a standard deviation of 23. I'd like to use that to estimate the percentage of dentists whose anesthetic usage falls roughly within a certain range. Right now, this might seem like kind of a silly question because it may seem like the numbers I have here, 56 and 102, are kind of random. We're going to develop some much more flexible ways to solve problems like this, which won't force us to use such strange numbers in Chapter 5. So stick with me for that. Okay. In the last video, I was asked to find an interval and that would contain the anesthetic use of about 95% of dentists. Here, I'm trying to work backwards. I'm given a range of values, so the interval from 56 up to 102, and I'm asked to find what percentage of my data, of my population, should fall within that interval. I think the easiest way to do that is probably to sketch a brand new version of my empirical rule picture, and instead of writing things like mu and mu plus sigma and mu plus 2 sigma, to start filling in some actual numbers. So here I'm starting in the middle at the mean, which is 79, and then I'm saying let's add one standard deviation to that and see where I get. 79 plus 23 plus 1 standard deviation brings me up to 102. If I add another standard deviation, so I add 23 to that, now I'm up to 125. And if I add yet another standard deviation to that, I'll land at 125 plus 23, or 148. Ticking down from the mean by one standard deviation at a time, it looks like the 79 minus 1 standard deviation would be 79 minus 23, or 56. Subtract off one more standard deviation, and I'm at 56 minus 23, which happens to be 33. Subtract off one more standard deviation, I'm at 33 minus 23, or just 10. I really hope the folks here at this lower end of the spectrum just aren't doing a lot of procedures that require pain control, because that's not very many units. Okay. Now, let's look for the numbers 56 and 102 on this diagram. All right. It looks like 102 here is just what I get if I start at the mean and I add one standard deviation. And 56 is what I get if I start at the mean and I subtract off one standard deviation. Now, I can refer to my handy empirical rule chart, and I can notice that the range from one standard deviation below the mean to one standard deviation above should contain about 68% of the data here. I've got 34% of dentists, approximately, using between 56 and 79 units, and between 79 and 102, another 34%. So that's my answer. All I have to do. So I'm going to buy this picture by the empirical rule. About 68% of dentists will have, I'm going to say, weekly anesthetic use between 56 and 102 units. Or, equivalently, instead of between 56 and 102, I could use some mathematical notation and say that's the same thing as in the interval from 56 up to 102. So, a little bit tricky because we're working backwards, but as you can see, the calculations that we're doing here are not too painful. We'll wrap this up with one example that I think is going to help you out with questions 4 and 5 on the worksheet. All of our questions so far have had to do with intervals or ranges of values. Now we're going to ask how many or what percentage of dentists use above a certain amount of local anesthetic per week. So how many, or I should really say what percent of dentists use more than 102 units of anesthetic per week. Now you might say, how am I supposed to know? You've only told me the empirical rule, which is all about intervals. But I'm going to claim that the empirical rule secretly tells you a lot more than that. Let's go back to our picture. Our kind of general picture with all of the labels, all of the details. Remember that 102 here is corresponding to mean plus 1 standard deviation. How much of your data is above that is going to go with a higher value? Well, it's going to be everything in the kind of tail that's to the right of mean plus 1 standard deviation. I can go ahead and start labeling areas on my graph. I see that I get 13.5% of dentists using between 102 and 125 units, 2.35% using between 125 and 148, and a tiny number above, just 0.15% going above 148. If I take all those three numbers and add them all together, if I add together all of the areas that are to the right of 102, I get 13.5% plus 2.35% plus 0.15%, which adds up to about 16% of dentists. So you can use the same logic on problems 4 and 5 of the worksheet. Figure out what kind of area under the graph represents the particular values that you're looking for, and then add up all of the areas that correspond to those values. Good luck, and I'm looking forward to seeing you Friday.